Hello world! In this video you'll learn everything you need to know to get started building your own React applications. By building 3 applications with React, of course. First you'll build the good old to-do app to get you familiar with the environment. Next, you'll build a weather app, which will help you learn how to integrate your apps with third-party APIs through the use of hooks, which is one of the core features of React. And finally, you'll build your very own portfolio website. I'll explain each concept thoroughly to ensure you grasp it well. However, if the video tends to be too long, I'll split it into 3 parts, each dedicated to one of the 3 projects, in order to ensure a high retention rate. Alright, let's begin. Before we begin, it's important to note that you must be comfortable with HTML and JavaScript first before progressing on to React. Because React is essentially HTML mixed with JavaScript renamed to JSX, so it's important for you to understand HTML and JavaScript before beginning React. Check out the description for some recommended resources to learn HTML and JavaScript. Now that we've got that out of the way, let's proceed to setting up our environment. Node.js is a JavaScript runtime, just a fancy term for an environment that enables the execution of JS code outside the browser. Just like how other programming languages have compilers used to compile and execute the codes on your system. So head over to the website and download the latest LTS version for your system. Once the download is complete, go ahead and install. After the installation is complete, confirm that the process was successful by running these scripts. If the versions are displayed, then everything went smoothly. If not, uninstall the program and restart the installation. If the issue still persists, join one of the communities and post your issue to get assistance. Check the description below for links. The next step is to select an IDE or code editor. Some popular ones include WebStorm, Cursor, and VS Code. I recommend Visual Studio Code for this tutorial. To download Visual Studio Code, head to the website and download for your system. Once you've downloaded the setup, go ahead and install. After installing VS Code, go over to the Extensions menu to install some recommended extensions. Search and install Prettier, ES7 Plus React Snippets, Auto Rename Tag. Alright, with all that done, let's create your first React application. Launch your terminal, and let's briefly cover some essential terminal commands. We'll use the pwd command to display the current working directory. We'll then use ls to list all subdirectories or folders and files in the current directory. Let's go ahead and create a folder to keep our projects using this command. Now, if we use the ls command again, we see the newly created folder. We'll now change our current directory using the cd command into our newly created directory. Using the ls command here will yield no result, since we don't have any files or folders here. If we print our current working directory again, you'll notice we're now in the dev directory. To go back to a previous directory, use the same cd command, followed by 2 dots. Alright, with that, let's go ahead and create our React app. Press Ctrl L to clear your screen. Go ahead and run this command to initialize a new Vite project. Vite is a modern build tool for the web that offers several advantages over the traditional method of creating React apps, especially when it comes to performance. After running the command, select React from the options, and then select JavaScript. Great! Our project has been created successfully. We can see that by using the ls command once more. There's a couple of things we must do now. Let's start by changing our current directory into the projects using the cd command. We'll now open this project in VS Code using this command. The dot used here means this current directory. This, in other words, is telling VS Code to launch at where I currently am in the terminal. Let's quickly go over the various folders and files we have in our project. The public folder holds static files like images. src contains the main code for your app. Gitignore tells Git which files to ignore. Index.html is the main web page where your React app loads. Package.json keeps track of project settings and installed tools, and README explains how to use the project. Now let's go ahead and install all the tools. In other words, our project's dependencies required to run this project using npm install. After the installation is complete, you'll notice the codebase has been updated with a Node Modules folder. This contains all the dependencies or necessary tools needed to run this project. With that done, let's run our app. We'll use npm run dev to start the Vite server, which will return a URL for us to see our running app. This command can be found in the package JSON file. A quick shortcut to open files instead of navigating with the mouse pointer is the Control key plus E. You can then search the intended file in this search box. If we now go to the URL, we'll see our running app. Alright, seems like everything is working. Let's go back to our codebase. Let's go ahead and open up .jsx file, which contains the contents of the app we just saw in the browser. We can see some sort of weird mixture of elements. This is what we call JSX. With JSX, we're able to mix JavaScript and HTML seamlessly. So, what is JSX and how does it work? First, let's clean these unwanted lines and dive into JSX. Now let's put a simple H1 with the text Hello World. After every change is made, make sure to save the file. JSX, like I mentioned earlier, is a mix of JS and HTML, and hence, we can have a JS variable whose value is an HTML element like this. And using this variable anywhere is going to render the HTML element we assign to it. Let's now make a few changes to this variable. We could also use constant variable definitions as well. Now what if we want to extract the name of the person to make it more dynamic? We can achieve that by extracting the name into a separate variable. Then to use this variable in the HTML here, we can put the name of the variable here. But once we save and view the app in the browser, we'll see that the compiler is rendering name literally instead of the JS variable. To fix this, we need a way to tell the compiler that this is not meant to be treated literally, but to be replaced with the value of the variable. And we do that by wrapping the variable with curly brackets. This will tell the compiler to put the value of the variable in this place. With that, we get our intended results. Components are essentially JS functions that returns HTML. Extracting our greetings variable from earlier into a component, we would need to define a function, and for its return statement, we'll return some HTML element. Now, in order to use this component, we must call it, but not like how you'd call a regular JS function. We'll call the component like this. We're getting an error here because for every component we must only return a single HTML. That said, we must wrap these two separate elements with a div or a fragment. By wrapping both elements with a div or fragment, we now have a single HTML element, instead of two separate elements. Let's go ahead and preview the results in the browser. Here you can see that the component is being rendered as it should, however, the greeting variable is being rendered literally, and if you remember, this is because the variable is inside the HTML element without curly brackets, and as a result, it's being rendered literally. Wrapping the variable with curly brackets fixes the issue, as you might have guessed. And also this syntax is what we call fragments. It's use when you want to group some elements together, but not particularly with a div element. Now let's move the name and greeting variables into the greeting component. Notice that we have an error here for using the greeting variable, and that is because we've moved the variable into another scope, unreachable by this component. Alright, our component seems functional enough. Now, when it comes to components, one of the benefits we have is reusability, meaning we can use this component wherever and as many times as we want. This is great, alright, but that also means we're repeating the same content several times, which is fine if that's the feature you want, but sometimes, when you reuse a component, you want it to have a slight variation from the rest, which is not possible with the current setup we have, as changing the value affects all other components. To fix this, components have a sidekick known as properties, or props for short. Just like how regular JS functions have parameters and arguments, we can pass these props to the components, giving each component a slight variation from the others. After passing the prop to the component, we can receive the prop object, access and use its properties as needed. And now, the prop value we passed is being used in the component. But as you can see, the other components having missing names here because we only passed the prop to the first component. To fix that, let's first look at a shorthand for using props. Since the props are essentially JS objects, we can destructure the properties we want from the object and use them directly, instead of always pre-pending with props. After destructuring the object props, we can assign what we call default values to the prop. This is essential to avoid any errors along the way. With the default value assigned, any component that we didn't give a name like the first component will use the default value. However, when the components receive their name props, the default value is skipped. I just realized that the font size is so huge after resetting my zoom level in the browser. If the same is with you, then let's head over to the CSS file and reduce the font size. Alright, now let's use our newly acquired knowledge of components and JSX to build a counter app. And while at it, we'll get to learn another core of React. This feature you'll find yourself using in almost every single app you build. The base of our counter is complete. Let's create a variable to keep track of the count. Now let's insert this variable into the HTML, and remember, we must put it inside curly brackets. Then let's add a button to increase the count. Now let's create the function and add an on-click event listener to the button to handle increasing the counter. Perfect. Now, let's start counting. Oops, something must be wrong. Why is the count not increasing? Well, actually, with respect to JavaScript, nothing is wrong here. The problem is the way React handles updating our interface. Let's log the counter in the browser console for a moment. So, as you can see, the count variable is indeed being increased, just that we can't see it, or perhaps React doesn't see a need to update the interface for us. Besides, it's just a simple counter app. This is discrimination. Let's tell React that this variable should be updated on the screen every time it changes. We'll do that by using what we call state variables. And this is how we initialize one for ourselves. The useState method returns an array whose first value is used to get the state's value, and whose second value is a setter function, which is used to update the value. And just like how we destructure properties from objects, we're destructuring the values from the returned array. Now with this setup, we can use the setter function to update the state variable by increasing the previous state by 1 every time this function is called. With this setup, the UI will be updated when the count value changes. But now, notice how the log in the console is behind the latest count value by 1. This is because when we access a state value immediately after updating it, like we're doing inside the increment function, we don't get the most latest version. Instead, we get the previous version. This is a React thing, and you don't need to worry about it. Just don't use a state variable immediately after updating it if you want the most latest version. To fix this minor issue, let's explore another cohort of the useState hook. These guys probably always walk side by side, and also don't forget that these hooks are to be imported at the top of the file.
This is the useEffect hook. Its syntax may seem cryptic at first, but you'll get used to it over time. It's used to synchronize a component with external systems, making it essential for tasks like fetching data or handling API calls. Inside this setup function, we'll write all our logic. The square brackets are used to track the setup function's dependencies. To fully grasp this hook, let's first explore a component's lifecycle. The React component lifecycle refers to the different stages a component goes through from creation to destruction. Understanding this lifecycle is crucial when working with React hooks like useEffect. The lifecycle is typically divided into 3 main phases: mount, update, unmount. The mount phase occurs when a component is first created and added to the DOM. During this phase, React initializes state, sets up event listeners if any, and performs any necessary side effects, such as executing the setup function of the useEffect hook if present. This could mean initiating a connection with an API or any other external service, but in our case, logging a state variable in the console. The second phase, update, simply occurs when a state variable changes. As a result, the component re-renders due to those changes in the state variable. This will in turn cause any side effect to rerun. The last phase, which is the unmount phase, happens when a component is removed from the DOM. This is the cleanup stage, where event listeners or API subscriptions should be cleared to avoid memory leaks. Don't worry too much if you do not really get the whole concept, as everything will begin to gradually make sense as you progress. Alright, moving on. So with our newly obtained knowledge of components' lifecycle, let's move this log statement into the setup function of the useEffect hook. And remember the dependency array. Any state variable we put in this array will cause the setup function to be re-executed, and in our case, we want the log every time the count variable changes. With this setup, we'll see the log in the console when the component is mounted. But as you can see, the log is displayed twice. This is as a result of React strict mode, which causes our components to render twice. With strict mode enabled, our components render twice, in order to detect errors caused by impure renderings among several others. It's best to leave this enable, but for demonstration purposes, head over to the main JSX file. Here you can remove or simply comment out the strict mode wrapper. And now you can see that the component only renders once. But as I mentioned, it's best to leave this enabled, as it might save you a few hours of headache in the future. And finally, back to the main cause of this whole detour, we now have the log in sync with the current count value. Alright, let's improve our super awesome counter app with a button to handle decreasing the counter. And, of course, we're going to change the onClick event handler of this button. Let's go ahead and create a function that reduces the value of the count state variable. Our basic counter app is complete. You could play around modifying the state value with different buttons and their event handlers. Go ahead and pause the video and add some more buttons to modify the count state. I'll be right here when you're done. Okay, hopefully you didn't totally mess up the app in the process. Let's move on. So let's just say you went into an interview for a React role, and there you were given this counter app. Your task is to make sure only positive integers are displayed. This will most likely not happen, but just in case it does, here's how we can achieve the desired output. With conditional rendering, we can choose to render elements to the DOM only when a condition is satisfied. In our case, we want to prevent the user from clicking the decrease button when the count reaches 0. Hence, we can conditionally render these buttons by rendering both buttons if the count is greater than 0, and only render the increment button if the count is exactly 0. This syntax is the ternary operator. It's a shorthand if-else statement that evaluates a condition and returns one of two expressions, the first if the condition is true, and the second if it's false. Like standard if-else statements, ternary operators can also be chained for more complex logic. With this setup, we'll have both buttons rendered if the count is more than 0, but we'll only get the increment button when the count is less or equal to 0. Alright, as you can see, the count is currently at 0, and as a result, we get only the increment button, but if the count is increased, then we also get the decrease button. Okay now, I think you're ready for your first production-ready React app. Don't forget to leave a like and share to support the channel. Alright, let's use our obtained knowledge to build our first project. Let's kick things off with a simple Hello World element. I'll then wrap the entire app with a div element. Then add an input element in the process. We'll also need a button for adding the task. Alright, now, we could set up an event listener to the button to update the to-do list. However, a better approach will be to use a form instead. Now, the button will submit the form when it's clicked. You can tell the form is being submitted because when we click the button, the page is reloaded. Now we can listen for the submit event on the form, which we'll use to handle updating our list. We'll now prevent the page from reloading when the form is submitted. Now, the page doesn't reload when the form is submitted. The next thing we'll do is to get the value entered into the input field, and we'll do that using a state variable. I'll main the getter variable input and the setter function setInput. And the initial value for this state will be an empty string. With that done, let's go ahead and bind the input field's value attribute to the state we just created. Then we'll listen for any changes on the input field and update the state variable with the input field's latest value. That's it. Now our input field is bound to the state variable. Whatever is typed in the input field will be stored in the state variable. For demonstration purposes, let's use the useEffect hook to log the state variable. Remember, with input in the dependency array, the setup function of the useEffect hook will be executed every time the input state variable is updated. Alright, we can now get the input field's value, but we don't have any list of tasks to add what we type into the input field. For that, let's create another state variable to store our list of tasks. The name of the state variable will be tasks, its setter function will be setTasks, and the initial value will be an empty array. Let's just manually add a couple of tasks in our list for demonstration. Each task will be represented by an object with a title and a complete to determine whether or not that task has been completed. Now using the map method, we're going to render these tasks in an unordered list. Alright, we used the map function to render each task as a list item in an unordered list, and we also added an extra ID property to each item to distinguish each item from the other. Now, let's implement the logic in the submit event handler. What we're going to do is really simple. When the form is submitted, we're going to add a new object to the task state variable. To do this, we'll use the setter function and update the state based on the previous value. Inside the callback, we'll spread the existing tasks into a new array and append a new task object, with the ID set to the length of the previous list +1, title set to the input state, and complete set to false. That's pretty much it. Now when we type into the field and submit the form, the task state will be updated with our new task. Let's clear the input field when the form is submitted. Alright, so as you can see, it works as it should. But what happens when we submit the form without typing anything? The list is updated with empty values. Let's quickly fix this. Okay, now we can't submit the form without typing into the field. However, what if we input a space character? The list is updated with empty values. To fix this, we'll update our logic to only modify the task state if the input is a truthy value. We'll use the trim method to remove any leading or trailing spaces from the input. If the trimmed result is truthy, we'll proceed with updating the tasks list. Alright, now let's add the ability to mark a task as complete. Before that, let's modify the return statement of the map function. Now, let's add an event handler to toggle the complete property of a task. But in order for us to mark the right task as complete, we need its ID. We can then pass the ID to the function, but doing it in this manner will execute the function as soon as the button is rendered. What we can do is use an inline callback instead. Now we can pass the ID to the function. Now, let's update a list by calling the setter function. And in the callback, we're mapping through the list and checking the ID of each task. If the task with the specific ID is found, we're spreading its properties into a new object and overwriting the complete property with the inverse of its previous state. With this logic, we can toggle the complete status of a task. Let's extract this into a variable to make it clean. Let's log the tasks to see the changes as they occur. Now that we have confirmed that the complete property changes, let's add some style to the list item to differentiate completed tasks from uncompleted tasks. Alright, everything is working just the way we want. Now let's take a look at another way to toggle the complete property of a task. You can go with whichever one is easier for you. First, we'll copy the elements from the task's state into a separate variable, as state variables should be treated as immutable. Now, to access a specific task, we'll use its ID. However, since arrays are zero-indexed while our task ID start from 1, we need to subtract 1 from the ID to get the correct index in the array. We can then update the complete property of the task. This will give us the same results, although once we mark a task as complete, we can no longer unmark it. To fix that, let's modify the property assignment. Alright, so whichever method you prefer, go with that. Now, let's change this button into a checkbox. Okay, let's use this button for deleting tasks. Let's now add an event listener to the button to delete a task from the list. Once again, passing an ID here in this manner will cause the function to be executed immediately when the button is rendered. We should rather use the inline callback. For the task deletion, we're going to use the filter method to return a new array which doesn't include the one task we deleted. Alright guys, this is it. Don't forget to like, subscribe, and turn on notifications as well. That way you'll get notified as soon as I upload another video. Thanks for watching, and I'll see you next time with another awesome video.